Good evening, everyone. My name is Chance Hamilton, and I will be proving the statement that 2 to the n is less than or equal to n factorial plus 2. 4 n greater than or equal to 3. Okay. So, what I'm going to do here is prove this statement that 2 to the n is less than or equal to 2 factorial plus 2 for n plus 3 by cases. Now, what you're probably thinking is that I'm going to sit here till the end of time and record me showing that this statement is true for every single number in the natural numbers, which goes up to infinity, but I'm not. So what I'm going to do is 3 cases, right? Case 1 is n equals to 3. Case 2, n is equal to 4. And then case 3 for when n is greater than or equal, just greater than 4. Okay? Now, the reason I'm doing this is because I am going to use a lemma to show that for n greater than 4, 2 to the n, that's 2n, 2 to the n is less than n factorial, which logically would have to be less than n factorial plus 2. Alright, so by induction, I'm going to be showing this right here. Okay, and I will conclude that this must also be true, which would prove my original statement. So I'm using lemma to prove that 2 to the n is less than n factorial, and that then I can conclude that this is less than n factorial plus 2. Right? So case 1, right? If I have 2 cubed, this is 8, and if I compare this to 2 cubed, 3 factorial plus 2, sorry for my laziness, that this is equal to 6 plus 2, which is 8, and indeed 8 is less than or equal to 8, so this case is true, right? And that was when we let n equal 3. And in case 2, we let n equal 4, and observe that 2 to the 4 is equal to 16, which is less than, I believe, 26, which is, yes, 4 factorial is 24, plus 2 is 26. Right? And again, indeed, 16 is less than or equal to 26. So this case is also true. Now we go to case 3, when we let n be greater than 4. Right? And this is where we're going to start our lemma, right? And this is where we actually will use induction. So I claim that for all n that are greater than 4, and in this case I'll just say equal to make my life easy, 2 to the n is strictly, well, I'll say equal to, again, to make my life easier so I can just continue with what I'm trying to prove, which is equal to. That 2 to the n is less than or equal to n factorial. Okay? So I will do this by induction. Now, this is typical for an induction case, is you first show the base case, which in this case is when n is equal to 4, right? And we just hold that this is true, right? So similar to what we did in cases 1 and 2, you do for induction, right? So I assume that n is equal to 4, and I observe that 2 to the 4, which is equal to 16, is indeed less than 24, which is equal to 4 factorial. Okay? So again, this base case is true, so I've established that my first number in the sequence makes the statement true. Right? So if I label this statement proposition A, right, A to the 4 is true. Right? So that's good. Step 2, also known as the induction step, right? As I like to think of it as the man who walks to infinity, right, in the induction. I let n be greater than 4 and assume A of n to be true, right? And I must show A of n plus 1 to be true, right? So by our assumption here, right, so we're assuming that this is true, so it must be the case that 2 to the n is less than n factorial, right? So if I multiply both of these sides by 2 on the left, right, I would have 2 to the n plus 1 is less than 2 times n factorial. Right? Now, note that since n is greater to the 4, right, then 2 clearly is less than n plus 1. Right? And because of this, I can also say that 2 to the n plus 1 must be less than 2 to the n factorial, which is less than n factorial plus 2. Oh, I'm sorry, not plus 2. I jumped to the wrong conclusion. N plus 1 times n factorial, right? Which implies then that 2 to the n plus 1 is less than n plus 1 factorial, right? So since I've established the base case, since we established the base case is true, and induction is true, A of n is true for all n greater than 4, right? Now, if we go back to our original case, when we let n equal 4, and my apologies, I used n twice here, but now I'm jumping to this n. Right? So if we bypass our lemma, since n is greater than 4, right, by lemma, it must be n, 2 to the n is less than or equal to n factorial, which actually would imply that 2 to the n is less than or equal to n factorial plus 2, right, for n greater than 4. All right? Now, since I proved for cases 1, 2, and 3, I have exhausted all possibilities of n. Therefore, 2 to the n is less than or equal to n factorial plus 2 for all n greater than or equal to 3. And that, ladies and gentlemen, is a mathematical mic drop, because that is proved. Thanks again. My name is Chance Hamilton, and please watch more of my videos. Thank you.